We're now ready to look at how triangles and trigonometric functions are related. So first, let's draw a triangle. So here's our triangle, and I've labeled the three sides: the adjacent side, ADJ, the opposite side, OPP, and the hypotenuse, HYP. Notice this is a right triangle. With my right angle, I've placed in the lower right-hand corner, and the angle we're interested in is this angle here in the lower left, and we'll call this angle theta. Our two base trig functions are sine of theta and cosine of theta. And sine of theta is defined to be the ratio of the length of the opposite side of the triangle with the hypotenuse of this triangle. There's a similar definition for cosine of theta that defines it as the ratio of the length of the adjacent side over the length of the hypotenuse. So these are our two base trig functions. Now there are four more trig functions, and all four of these can be written in terms of sines and cosines. Let's start with tangent of theta. The tangent of theta is the ratio sine of theta over cosine of theta. Cosecant of theta is simply 1 over the sine of theta, or the reciprocal of our sine theta function. Similarly, secant of theta is 1 over cosine theta. And tangent also has a reciprocal function, and that is cotangent of theta, which is defined as cosine theta over sine theta. So using these definitions in terms of our two base trig functions, we can write each of our remaining trig functions in terms of the sides of the triangle. So if I replace sine theta with opposite over hypotenuse, and cosine theta with adjacent over hypotenuse, I see that the hypotenuse in each denominator cancels, and I can simply write the ratio opposite over adjacent. So the tangent of theta can be found by considering the length of the opposite divided by the length of the adjacent side of our triangle. Cosecant is even easier. It's the reciprocal of the sine. So I just flip my fraction here to write the reciprocal and have hypotenuse over opposite. Secant is the reciprocal of cosine, so we have hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so this becomes adjacent over opposite. So remembering these ratios for a triangle is helpful in evaluating our trig functions. And we're going to need to be able to evaluate our trig functions at a few particularly nice angles. So let's look at one of those. We're going to consider the triangle for the angle theta equals pi over 6. So this is one of our nice angles. And this pi over 6 is in radians, which is the same as 30 degrees. And we're going to just determine the value for cosine theta, sine theta, and tangent of theta. So the first thing I'm going to do is draw the triangle for pi over 6 and label my sides with their actual values. So this is our standard pi over 6 triangle. Notice it's a pretty small angle, and the adjacent side is longer than the opposite side. So here, our adjacent side is root 3, our opposite is 1, and our hypotenuse, using Pythagorean's theorem, we can solve to be 2. So looking at my trig functions, here I've ordered them sine theta, cosine theta, tangent theta, and the ratios I have listed over here on the left. I see that the sine theta is the opposite over the hypotenuse, so I have a half. Cosine theta is adjacent over hypotenuse, which gives me root 3 over 2. And tangent theta is opposite over adjacent, or 1 over root 3. Now I said that we have a few angles that are the nice angles that we need to be able to evaluate. The other two triangles that are really helpful to remember are the pi over 3 triangle and the pi over 4 triangle. Now the pi over 3 triangle is actually this exact same triangle, only reoriented. So I'm going to put this opposite side and make it an adjacent side and look at the other angle. When I flip my triangle to make the side that's length 1 the adjacent side of my triangle, so it's along like an x-axis, say, my opposite side becomes root 3 and my hypotenuse remains 2. So I have essentially the same triangle, but I've just reoriented it, and I'm looking at the bigger of the two angles. The pi over 4 triangle is a 45, 45, 90 triangle. So our lengths of our two legs that create our 90-degree angle are the same, and we will label those for convenience a value of 1. So the adjacent is 1 and the opposite is 1. Solving for the hypotenuse, I get the value root 2. So it's worth remembering these three triangles, pi over 6, pi over 3, and pi over 4, in order to simplify evaluation of our trig functions.